For decades, the official picture of the first great human journeys looked almost settled, until a lock of Aboriginal Australian hair forced scientists to reopen the map. By the end of this story, you will understand why one small physical sample pointed to one of the deepest human lineages outside Africa, and why part of that record still has no fossil name. In 2011, researchers sequenced the first Aboriginal genome from hair kept for roughly a century after it had been donated in Western Australia. The study, published in Science and led by Eske Willerslev, turned an old archive object into evidence with a pulse. Imagine the careful room around it: sealed containers, quiet machines, the faint clean smell of laboratory alcohol, gloved hands holding something lighter than thread. It suggested that ancient Aboriginal Australian DNA carried a branch of human history that had separated very early from other populations outside Africa. And that was only the first opening in the puzzle, because one genome could raise the question, but it could not yet show how far back the answer went. If you want more deep human history like this, subscribe and keep listening. That first genome did something rare in science. It made an old assumption feel suddenly too small. In the clean hum of the lab, where screens glowed blue and the air had that sharp, sterile smell, the data pointed to a branch of ancestry older than many expected. Researchers were not looking at a myth or a family story. They were reading inherited markers, letter by letter, through machines that clicked and warmed under bright white lights. The pattern suggested that the Aboriginal Australian ancestry had separated very early from other non-African populations, deep enough that the usual map of human movement began to blur at the edges. Then came the harder question: was that century-old sample a strange exception, or a doorway into a much larger record? To answer it, scientists needed more than one genome. They needed living communities, careful consent, comparison, and a wider set of data. Years later, that wider study would arrive in Nature, built from 83 Aboriginal Australian genomes. And when the molecular clock was applied to them, the date range it produced was not small. It stretched back roughly 51,000 to 72,000 years, far enough to make the next discovery feel even more unsettling. That wide date range mattered because it placed the ancestry of Aboriginal Australians near the earliest chapters of the human story outside Africa. In the Nature study, those 83 genomes did not form a small side note. They formed a deep branch, measured through shared mutations, population models, and the slow tick of inherited change. Picture the work behind that sentence. Researchers leaning over charts, the dry rustle of printed tables, coffee cooling beside keyboards, colored lines spreading across screens like river channels. Each line represented a comparison: who shared what marker, how long it may have been carried, and where one population's path separated from another. The result was careful, not casual. Roughly 51,000 to 72,000 years ago, the ancestors of Aboriginal Australians appear to have split from the ancestry leading to many other living groups. That does not mean a frozen people outside history. It means a record with extraordinary depth survived in their DNA. But the molecular clock is still a clock built from assumptions. Mutation rates can be estimated in more than one way. Ancient population mixtures can blur the hands. And just as the genes pointed backward, the ground in Australia began asking its own question. The ground's question came from the places where people had lived, worked, cooked, painted, and left tools behind. In northern Australia, archaeologists have studied deep layers of shelter floors, where stone flakes, ochre, and ash sit packed in earth that smells of dust, mineral, and old smoke when it is opened. Those layers matter because they offer a second kind of clock. Genetics counts inherited changes. Archaeology reads the position of objects in soil, the age of nearby material, and the way sediment has settled over time. When both clocks point in the same direction, the story grows stronger. When they do not line up cleanly, the puzzle becomes sharper. Some evidence has been read as showing people in Australia very early, possibly around the older end of the genetic range. Other researchers urge caution. Sandy ground can shift, small artifacts can move. Dating a human presence is never as simple as holding up one stone and naming a year. So the safest statement is still powerful. Aboriginal ancestors were on the continent tens of thousands of years ago, with a genetic record reaching deep into that first arrival. Before that arrival, their DNA shows they met another human population entirely. That meeting shows up as Denisovan DNA, still carried in Aboriginal Australian genomes today. The amount is small by ordinary speech, around 3 to 5%, but in human history that is a loud signal. It means the ancestors on the road toward Australia did not travel through an empty world. Denisovans are one of the strangest known branches of the human family. For a long time, scientists did not have a full skeleton to study or a face to reconstruct with confidence. They had fragments, ancient DNA, and the cold work of comparison. In the lab, it is easy to imagine the stillness around those samples. Plastic trays, soft machine beeps, the faint heat from computer towers, and a screen where old ancestry appears as coloured bands. The Denisovan blueprint in Aboriginal and nearby Oceanian populations suggests contact before arrival on the continent, somewhere along the complex routes through Asia and island Southeast Asia. It was an encounter written into descendants, not into a carved monument. But when the 83 genomes were examined more closely, one part of the pattern did not behave like ordinary Denisovan ancestry. It looked related and yet separate. The separate pattern is where the story becomes almost impossible to picture. The researchers could compare it with known ancient DNA, including Denisovan and Neanderthal samples, and yet part of the signal still sat outside the expected boxes. It was Denisovan-like, close enough to suggest a distant relationship. But it was distinct enough that the team described it as coming from an uncharacterized hominin population. In plain language, that means another ancient human group left traces in the ancestors of Aboriginal Australians, and science has not yet matched those traces to bones in the ground. Think about that for a moment. No confirmed skull, no named face, no clear fossil hand resting in a museum drawer. Just fragments in genomes, seen through models, comparisons, and careful doubt. The evidence is quiet, but it is not empty. It is a genetic signature from people who seem to have stood somewhere along the route towards Sahul. Researchers have suggested possibilities, but the honest answer remains unfinished. The lineage may have been close to Denisovans or part of a wider human landscape we have barely sampled. If a whole population can be visible only through DNA, what else has the fossil record failed to hold? The failure of the fossil record is exactly why the DNA matters so much. A bone can break, a burial can vanish, a cave can stay undiscovered for thousands of years. Inherited fragments can pass quietly from parent to child through heat, flood, hunger, travel, and time. In this case, scientists were not holding the unknown group in their hands. They were seeing its outline by subtraction. Compare the Aboriginal genomes with modern humans. Compare them with Neanderthals. Compare them with Denisovans. Then look at what still does not fit. In a room full of soft fan noise and pale monitor light, that leftover pattern becomes evidence. This is why the phrase ghost lineage is so powerful. It does not mean fantasy. It means a population known through traces like footsteps pressed into wet clay after the walker has gone. The ancient Aboriginal Australian DNA kept part of that encounter, even when stone and bone did not. Then the puzzle changed shape again. After those early meetings, after the long movement toward Australia, the genetic record began showing something rare in human history. People arrived, and their descendants stayed tied to place for an almost unimaginable span. The long tie to place is one of the most delicate findings in the whole story. The DNA suggests that after the first settlement of Australia, Aboriginal groups remained connected to the same broad regions for roughly 50,000 years. Say that slowly, because it is easy to hear it the wrong way. This does not mean nothing changed. People moved, married, traded, adapted, remembered, and rebuilt through enormous shifts in climate and coastline. Sea levels rose, old shorelines vanished underwater, dry country expanded and pulled back. The air itself would have changed smell from coast salt to hot spinifex, from wet earth to red dust. What the genomes show is a deep regional pattern. A person's ancestry often matched the broad area where their community belonged. That kind of continuity is rare on this scale, and it forces science to read the data with respect for country, language, and living connection. The confirmed finding is powerful. The ancient record inside Aboriginal Australian DNA is also a record of place. Then, much later, after tens of thousands of years of regional depth, another signal moved across the continent, and it did not behave like the old patterns at all. The later signal is difficult because it sits on top of very old continuity. In some genetic studies, researchers see signs of movement within Australia long after the first settlement, a kind of pulse crossing older regional patterns. It may connect with the spread of languages, marriage networks, ritual exchange, or social change. Scientists are careful here, because DNA alone cannot tell us what people believed, what ceremonies traveled, or what agreements carried families across distance. A genome can show contact. It cannot translate a songline or name the reason a group moved. Still, the pattern is there. Imagine a map under low light with older regional lines lying deep like carved grooves and then a newer trace moving across them. It adds another layer. Change moving through a continent that already held tens of thousands of years of local history. This is where the story becomes most humbling. Ancient Aboriginal Australian DNA contains early separation, Denisovan ancestry, an unknown hominin signal, and deep regional continuity, all in the same living record. To understand why that changes human origins, we have to put the pieces together one last time and ask what the textbooks still leave out. Put the pieces together, and the old human map no longer looks like a clean set of arrows. It looks layered. A century-old hair sample, published in Science in 2011, opened the first door. The Nature study in 2016 widened it with 83 genomes, and the split it measured reached back roughly 51,000 to 72,000 years. Then came the deeper marks. Around 3 to 5% Denisovan ancestry, a second Denisovan-like signal from an uncharacterized hominin with no confirmed fossil record, and a regional continuity across Australia stretching for about 50,000 years. Ancient Aboriginal Australian DNA and the ghost hominin lineage, still carried by living people, show why human origins cannot be told from bones alone. The hidden record is not resting in one cave or one cabinet. It is carried through families, through country, through living communities whose histories deserve care, consent, and precision. Some questions remain open, and that is part of the wonder. In a laboratory, the machines go quiet at night. On the screen, the lines remain. Old branches, faint traces, and names science has not found yet. If this changed how you picture the human story, leave a comment with the question you want researchers to answer next, and subscribe for more deep history told through evidence.